Hi everybody, thanks Chris, and thanks to Darwin for giving us the opportunity. We have partnered with Darwin. Ek kan Afrikaans ook praat as jy laat my nie mooi verstaan nie. We have partnered with Darwin, and we believe we have synergy, especially with the product that they've got, that we've spoken about earlier. We are doing trials to see how the bacteria performs with it, but I'll give a little bit of insight into bacteria. My background before flying airplanes, I'm involved in agriculture. I used to farm. I was a dairy farmer as well. Did vineyards, did sheep. So I think I'm on the same page as you guys. I know what it is to farm. It's not easy. If it was easy, everybody would be doing it. Huh? All right. Okay. Blue Planet, American company, been around since '74, making biological products, producing bacteria, different consortiums. They were mainly in wastewater, and then they found that, hey, the wastewater we're treating, we're actually getting crop enhancement. So they started to look at this very, very carefully. And the laboratory where they produced was in South America, was in Miami, or Florida, what was called Miami, capital of South America. There's more Spanish spoken there than is English. And a lot of the trials are done down in South America, on all varieties, and they got incredible results by getting microbes into the soil and getting the biology right in the soil. That's what it's about. Unfortunately, we can only show you what it looks like there, but we've got to prove it here, which we've been doing. Blue Planet South Africa was formed in last year, the beginning of last year, in conjunction with VS Agri in the Free State. They have quite a big footprint in the Free State, and being a bunch of farmers who formed their own co-op, it's given us, well, right through the Free State into Northwest Limpopo and Mpumalanga, where we are doing extensive trials. We've had some incredible results on a lot of crops, but one swallow doesn't make a summer, so it's ongoing. Okay, we're going to be doing 1,000 hectares a week this season. If the guys can get in, I believe it's very wet, they can't plow properly. We're addressing nematode problems. We have a product that we are trialing at the moment that's very, very exciting by Dr. Ricky Ferrie in the Northwest Province at the University in Potch. And we are now also busy in the sugarcane. I don't know if you guys know what's happened in the sugarcane industry. They've been hit by this longhorn beetle. I think there's 500 hectares that's been infested with it, and we are busy doing trials. In fact, they were done last week. Very exciting development by using not only our products, but some of VS Agri's products in liquid ammonia gas. We found that it does destroy the longhorn beetle and the pupae. But with the high ammonia concentrates, we have to rehabilitate the soil, and that's what we put in our bacteria with it. So very exciting times, and I've had huge successes in wastewater. I clean up a lot of wastewater. That's been my main concentration. I firmly believe you've got your water right, the rest is you're halfway there to getting everything else right. Once your soil and your water right, you're away. One thing I have done is clean up a couple of pig dams, big slurry dams, and I've always said, when it comes to slurry dams, it's always been a hassle for everybody. And I believe that by the right treatment, we're going to turn that hassle into an asset. And I'll tell you why I think that. And in Ireland, we've been getting incredible results on treatment of pastures, which I'll explain to you now. In Europe, you're not allowed to put slurry on lands anymore. And I'll explain to you why. All right. Just quickly, anybody talks about bacteria, there's a lot of what we call snake oil in the market. And if I reduce this, you can see everything, I think. There we go. Can you all see that from the back, or is it too small?
No, it's fine.
Okay. Let's go one darling. We have 6 species and 4 genes in our mix. Okay. Most products in the market will have 1 gene and a whole bunch of species. You might get 2 genes if you're lucky. What predominantly is in the market is bacillus bacteria, which everybody sells bacillus. They bring it in a freeze-dried form and they rehydrate it in water. It needs a food source, and so they put molasses in. Bacteria is very, very clever. They've actually got to the stage now where they actually realize bacteria actually communicate with each other. And it will actually teach itself to bioremediate whatever, if it needs a food source. Our bacteria is all stabilized in the laboratory. We put recognition compounds in, so it will only go for certain things that we have taught it to do. We're one of 2 companies that I know of. The other company is using our old formula, that we have live bacteria. We have a powder and we have live bacteria. Live bacteria is put to sleep with hydrogen sulfide. It has a shelf life of 2 years. Okay. All the other products using bacillus base and rehydrated from freeze-dried powder has a shelf life of about 3 months, maybe 6 months, but you'll see the can will start blowing up, and it's invariably black. Sometimes they put a colorant in it and they make it green or whatever. They get limited success with it. I'm not knocking it, but it's not the full Monty. Some people will come to you with enzymes and tell you that it's bacteria and it's not bacteria. Enzymes play a very important part in the bioremediation process. Okay, so this is our mix, and if you look, Rhodocydinomus pilostrus, that's a mouthful, it's very difficult to say. But it will tell you everything that our bacteria does. There are some plantaceas that Cornell. Okay, if you put your email addresses on that list, we will email you all the stuff I'm talking about, so you can, in your own leisure, look at it, okay, and just read what it's about. But you can see what it's about. When we talk about water, I'll come on to it now, we talk about aerobic, anaerobic, and facultative, and then we talk about the sludge at the bottom, okay? And we talk about photosynthetic values in there. But this will degrade. The big one here for you guys is hydrocarbons and nitrogen fixation. And then bacillus subtilis will come down, we'll tell you what everyone does, degrade of ammonia, from organic compounds, etc., etc. That's quite interesting because we're using some of that to attack nematodes. So we've got the full range out. I know we're short on time, I don't want to get too carried away with it, but we talk about phosphate solubilization. We talk about breaking down ammonia to nitrite back to nitrate, and then back to nitrogen, which is part of your nitrogen cycle, and I'll explain to that. Okay? And then all that does further on, it gives you all our different products, what they do, what they contain. Interestingly, we were talking about humic and fulvic acid. We have a product here, SA, and we use fulvic and humic acid. We get incredible results on plants where we do root dipping. If you take a fruit tree or even an orange lemon tree, when you take it out that basket, out the punnet, and you put it in the ground, there's always a bit of a shock to it. And we seem to be getting good result with this, with a crossover into the ground from the nursery. Okay. As I said, we have dry spore powder, which we use on a very big scale. We cleaned up North End Lake with it, where we brewed. We call it a brew or a bioreactor. We put powders in and we rehydrate it at 27 degrees with sterile water, and we aerate it vigorously. We add the live bacteria in with it. The difference is in our dry powder and everything else in the market, and this is actually being patented as we speak in the States, is that we don't use molasses. We have food in it, and we have recognition compounds in that mix. Okay? It's a long story. I'll explain it to you later if we do meet again, and it works very well. We cleaned up the Esther River at Speed Wine Cellar, where it was raw sewage in the river. They couldn't entertain their guests because everything's outside there. Over the Christmas period, we cleaned the smell up in 1 week, and I've got a test case here, and we broke everything down. It's ongoing. These huge political ramifications, and there are probably going to be court cases. But the Plankenberg, Stellenbosch town, is just dumping all the sewage in the river. It's the state of the nation, unfortunately. That's the way it is. But we treat sewage water very well. So I'll get on to dairy effluent, what I'm here for. Okay. As I said to you, the European Union and I don't think we're far behind, has stopped all slurry spreading onto pastures, onto grasslands. That is why anaerobic digesters have become so big in Europe. We all know what anaerobic digester is, where they take manure, whatever they take, the food source they've got, and they produce methane gas. Okay? Remember, all this is always a byproduct, one of its methane, and they generate electricity from it. They actually grow crops to put in to enhance anaerobic digestion. Okay? And that's one way they've got rid of it. Why don't they like it? Because all waste, whether it comes from humans or animals, is high in normally CODs, which is chemical oxygen demand, which is the amount of oxygen in the water to sustain life. The higher the figure, the more poisonous the water is, the less it is to sustain what we call higher life, fishes and plants and that sort of thing. Ammonia is very, very high, phosphorus is high, and TSS, total suspended solids. Okay? You'll get TDS, or total dissolved solid, which is normally inorganic. But suspended solids, if you look at a sludge build up in a sewage farm from human waste, is unbelievable. You have the same in your slurry pits. You see all the waste. Those are solids. Everything's organic. We can break that all down with bacteria, and we do break it down. Okay? When you distribute that onto your lands, you are putting an effluent down low in oxygen. You're putting down suspended solids, which is going to lead to thatching compaction later on, which it does. You know that. High ammonias and high phosphorus. What do we know about ammonia? Ammonia is not natural in life. It's a man-made thing. We call it higher life. It comes from animals and humans. When everybody lived over a huge area, there was enough bacteria to take care of. Now we're all living on top of each other. There's not enough bacteria to break it down. Okay. So ammonia has to be broken down to nitrite, back into nitrogen. Okay. Ammonia is very good when you put a seed in the ground, as you guys know, but once it's out, it needs nitrogen. All plants need nitrogen. Nitrogen is what we're all living on. Okay. So let's just go down with it. I've written it all down here. You have odor problems, we break the odor down. We do that very, very well. What is odor? It's hydrogen sulfide. Okay. Where does it come from? It comes from your sludge. Everything happens in the sludge in the slurry pit. That's where your methane buildup comes from, your CH4, H2S. And what it does, it piggybacks up and it comes to the top. Every now and then, if it's been left for a while, you'll see natural methane coming out. You'll see the bubbles. Mense het nog gesê, "O, kyk hoe dam, kyk hoe borrel as baie vis." That's actually methane. Okay, all right, high levels of ammonia, phosphorus, I told you, suspended solid CODs, and sludge buildup is harmful, is a breeding ground for pathogens, guys. We're talking about E. coli, coliforms. Down our way, there's a guy that dives and he fixes the piping on irrigation dams. And a friend of mine bought a wine farm there, and I fixed the irrigation for him, and I put a floating suction on. He got involved in that sludge down there, and he put a cascade coupling on, and he put a floating suction on where the better water was, because you got oxygenated water. And about, 8 months later, the guy nearly died. He got tetanus. And that was from that sludge. So we've got all kinds of pathogens. When we did North End Lake, we bioremediated in 14 months 115,000 cubes of sludge out of there. Okay. How did we measure it? We took GPS points. We take a meter of clear piping, we put 10 centimeters on, connected, marks on 10 centimeters marks, and then we screwed up onto another 50 more pipe. And with a piece of rope down the middle, a tennis ball, we stick it into the sludge so we can go no more. We pull the tennis ball out, pull it out, and we see exactly how much compacted sludge we've got. Okay, so that's how we measured it. So we took the surface area, we took these GPS points, and we measured it down. That lake was high in pathogens, phenols. You can't believe it. I mean, those guys catch the fish there, PCBs, they catch the fish, and they're eating it, and they poison themselves. They did an incredible thing where they put in gabions, which is these wire baskets with stones in. Africa did that. Brilliant idea. We could see what was coming into that lake. Raw sewage, powdered milk, slaughter waste, especially pigs. Guys slaughtering in their backyards, throwing it down. Oil, engine oil. Guys in the taxis pull over the storm drains, loosen the sun, drop it down, off they go. We broke down everything. We break down hydrocarbons. We've done oil cleanups in soil, very successful. We did one in Joburg in 2010. So we got all the parameters right, and then there was a bit of political change, and it's now this and it's that, and they've stopped, and the lakes came back to what it was, highly toxic. Okay. So that is the sludge buildup. So those guys that are water skiing and swimming in that lake, they're looking for a hiding, really. All right, so I spoke about methane, hydrogen sulfide for you. Okay. If you look at our bacteria species, we actually break down sulfurs. Okay, we call them mercaptans, which is organic sulfur. Okay, not elemental sulfur, organic sulfur we break down. It's the first thing we do. So, in true bioremediation, once you take the sulfur out, you've got H2. Okay, what does it do? It piggybacks in the methane, comes to the top, gets oxygen, and we go back to H2O. So the byproduct anaerobic digestion is H2O and CH4 methane gas. In anaerobic, the top half where there's oxygen, it is carbon dioxide, CO2, and once again H2O. Okay. So let's just go here quickly. That's a pig dam up near Potchefstroom. That's a slurry dam. What happens to it if it's not remediated? It gets this crust on the top. Now where you see the clear, those white patches, that's where the methane's coming through. It's actually breaking through. Okay. We bioremediated that. When they stuck, they've also got one of these vacuum suckers, these tanks, 9,000 litre tanks, and he spreads it out. When they actually folded it, and we actually blew it back, and we broke the crust when we started, it actually erupted. You couldn't believe what came out of how much methane gas was developed under that lot. The way I like to break it up, if the guy's got a sequence of dams, I take the last dam, which I put a little bit of bacteria and I polish it, and I pump it back, and I spray it over, and I prop it. So remember, bacteria, you're not only breaking the dam with impact, but actually getting it moist so the bacteria can bioremediate from the top and from the bottom. Because that dam is now in an anaerobic state, or it was. And once it's anaerobic, it's very difficult to break down. Because about 70% of your bacteria is aerobic and the rest is anaerobic. Okay. Remember, bacteria is here. What is affected? pH, water pH we're talking about. We are mesophilic bacteria. It lives from 5 degrees to 45 degrees. pH of 4 to 10, ideal 5.5 to 8.5. That's what I want my water at, if I can get it there. I do winery effluent, 4.2. It works, but it goes very slow. Once we get that pH over 5.5, boy, we knock out the mercaptans, and we knock out the phosphorus. We get rid of the smell, and we get the CODs down. I've done it with dairy effluent, where there's fat, thick as you can, thick like that. Abattoirs up in Freiburg, the crust is so thick the guys walk across it. And that's the only way, it speeds it up. You can halve the time of the bioremediation to get your thing right, your pond right. Okay. There we go. That's basically it. Can you see that? That's basically the pond here. That's your that's your aerobic zone, LD, and then you get your aerobic here, facultative, anaerobic sludge in and your anaerobic zone down there. Sorry, it's not very good, it didn't come out very nice, but it gives you the different gas, the circulation. Now we talk about CH4, some nitrogen, and H2S. Okay? Looks better here on the computer in front of me. Okay. Then I've gone on to give you the different bacteria species which I gave to you before. We talk about solubilizing, making it, whatever it is, better for plant uptake. Like phosphorus, we solubilize phosphorus, better uptake of the plant. Remember, we don't kill anything. When it comes to pathogens, we don't kill anything. We take away its food source. If you've got algae problems in your cribs or on your dams and you've got a big network, you put a dam on the top and it gravities down to all your water cribs, you get a green algae, and what is that? That's high nutrients, okay, in your water. With a bit of sunshine, beautiful. Just you get an algae bloom. I've got an algae bloom on North End Lake over a hot weekend because we had remediated a lot of the ammonia and we had high nutrient values when we did the analysis. And one weekend, I thought somebody had thrown green paint in sections of that dam. And once we threw the bacteria in, I think it took us 5 days and we knocked it out. But if you've got cribs with that problem, we just treat your dam on a very low dosage. And it'll take 3 weeks, 4 weeks, I don't know. In remediation times, we can never give you an exact time. And you will have end of your problem. You won't have algae in your cribs anymore. I've done that up in the Free State and the Transvaal, West Transvaal. Okay, so this is the same one I put down for you. I just put it in this document. And then we come on as a microbial biofertilizer. Our time is limited. We can talk about nitrogen recycling, humus formation, okay? What it says here is important that ammonia be converted to nitrates, or nitrates, because ammonia gas can be toxic to plants. Previous guy spoke about all this stuff. I'm not going to go through it again, okay? But this is what our bacteria does. That's why we're so excited to work in conjunction with Darby and Company. We're going to be putting the bacteria in with the AminoFix. So we're very excited what's going to happen there. Okay, we talk about humus formation, all to do with plant growth, okay? We talk about phosphorus solubilization, we talk about sulfur production, plant growth hormone production, nitrogen fixation, there's a whole lot of growth promoting bacteria. Okay, so there we go, okay. This I'll all send to you guys, can read in your own time. There's no point repeating everything that has been said before. This is a pig slurry dam I did. That's what it looked like when it started. Incoming here, 4 dams. One, another one up here, 3. That gets mixed in and now went into the center pivots. If you take the Department of Agriculture, Water Affairs, they have a discharge standard, and there's nobody to enforce it. It's the same with the sewage farms around the country. I mean, you don't believe what we see. We are busy cleaning up. We've done Fredderfort, we've done Stonesrus, and we've just got Parys now to clean up. They're all overloaded, and it's just raw sewage into the water. Our water's all contaminated. On the Vaal River scheme into the Vaal Dam, there are 21 towns that are on the river of the Volga and on the Vaal River. Not one of them conform. In Fredderfort, there's a family there that has the rights to use the water for irrigation. They've got a huge centre pivot. They haven't been able to use it for 8 years. The water analysis is not fit for animal human consumption. All that's going into the Vaal Dam. Even the guys down at Foul Hearts are being affected by that irrigation water now. We don't realise we're in a bad way, in a very, very bad way. When it comes to discharge standards, I'll give you CODs. The chemical oxygen demand, they want it under 400. They want your ammonia, if you're under 500 cubes a day, at 6 milligrams on a litre. They want, if you're above that, they want it under 2 milligrams a litre, if you pump up to 2,000 cubes. They want phosphorus 10 milligrams a litre under. And I can tell you now, if you don't treat it, nobody's conforming. But there's nobody to enforce it. We have incredible water laws, but there's nobody to enforce it. Unfortunately, the biggest polluters are the people who wrote the laws. It's a very sad situation there. Okay, so that was the slimes dam. I did another one of their dams on another pig farm. Remember what I told you about discharge standards? The COD was 27,000. The ammonia Sorry, the ammonia was 2,240 milligrams a litre. It's got to be under 6. They spread it. They also use one of the vacuum suction carts. 230 hectares. They destroyed it. They planted wheat in it, and it got that high. And that was it. Nothing happened. They then cleared another 230 hectares of Port Jackson, and they're still busy dumping that. That was 2 years ago, and it's still going on. When I spoke to the pig farmer about it, he said, "The soil needs ammonia." What are you talking about? You know what you're talking about. There we go. Okay, so that was the same dam. You can just see it going, and there we're starting to see a result. You see these here, that is actually methane coming out. You can see all the solids here as we've broken the crust down. What I did there too, also, two of the dams are very crusted. I actually circulated and I sprayed water on the top and got a quicker result. Okay, and that's it. That was, I don't know how many months that was. Well, that's a couple of months. You can see that's still number one dam. You can see those islands there, that's still coming up. That's sludge that's coming up to the bottom. As we biodegrade it, releases the methane, and the parts actually come back. I was with, 2 weeks ago, I was in George at Hookwell with Mark Rubin from Lancewood. Dam that hadn't been cleaned for about 12 years. Big problem when he pumps it out. Irrigated to center pivot, the solids plug up the holes, in the nozzle, so he sits with the problem. Plus, as I said, what solids get through is causing great compaction for him, and it's all organic, and we can break it down. It's a fantastic carbon source. So anyway, we went there. He said he hadn't been for I think it was 3 weeks we started treatment. And he said, "Oh, your stuff's not working." I said, "Of course it's working, Mark." So he said, "No, he hadn't been there." We went there, and I'm not lying to you, it was like a kettle. It was bubbling, and pieces like that were coming out in the first dam as it was cooking. And we'll get his water right, and he will then have a valued crop to add onto his pastures. Because we're going to break down this, bring the CODs down, break down that phosphorus, solubilize the phosphorus, and break down that ammonia for him, and reduce his solids. And that bacteria is going with it. It's going to go into his soil, into his ground. You're going to see plant growth. We are doing a trial in George. Guy does a lot of work for the farmers in soil preparation. He's got a ripper, but he's modded it with a tank on. So I think it's a 1,000-litre tank. And if we put in a pipe down right at the back of the tine. So he's ripping that deep, and I'm going to put our bacteria in there with his moisture. Remember, bacteria needs moisture to survive. What destroys bacteria? pH, chemicals, harmful chemicals, water temperature when it comes to water, and moisture. So if you're using it in agriculture, we need that moisture in the soil. Where we have droughts, unfortunately, the bacteria is not going to survive. So dry land is very hit and miss. Last year in the drought in the Free State, where we did a maize trial, we didn't get a result because we put the bacteria with the planting. It came out, and we did a foliage spray, and we got 860 something kilos, 0.86 tons more on that block. So we just need the moisture. We need to play with more. Where it's under center pivot, it's a win-win because we can control the moisture in the water. We did a wheat trial at Rock Beaumont in Frankfurt, and we got 34% more wheat. But as I said, one trial, one swallow doesn't make a summer, so it's ongoing. We need to prove it. You're working with nature, you need to prove it all the time. Okay? We've seen the results from what the Yanks did, and they got good results. Okay, so that was the part at the end of the day. It was an ongoing treatment. Okay, that just gives you the nitrogen cycle. Okay, what I was talking about. That little cow didn't come out there. I don't know why, but that's what we call higher life. Ammonia, nitrate. There's the bacteria that breaks it down. Nitrate to nitrite to nitrate. Sorry, there's the bacteria there. The denitrification cycle back to nitrogen. Okay, this was talking about what they call, we talk about compaction, they talk about thatching. This is a golf course in Cape Town, a guy called Steenberg. It was a wine farm. Funny enough, it's a relation, it was the second cousin of my mother, Nicholas Lowe, used to have that farm. But they use sewage water from the Cape Flats. They pump it up, and it goes into the 18th hole. They have a dam, and they had 800 millimeters of silt build up, sludge. And they were in all kinds of problems. And they were getting thatching. We took a soil sample when I went there, and I went client, it was like a tar out on the street. The root system was that deep. Grass was dying, southeaster blows, they can throw all the water they like. The water was contaminated, as I said, sewage water, high CODs, ammonia, phosphorus, and solids. Okay? So this was just the practice chipping green. Okay? We treated there with that one with humic and fulvic acid. And that was the difference in the green. But what I want to show you is the roots. There you can see the difference. That was how many weeks? From the 4th to the 5th. We had 4 months to clean it up. We gave them a guarantee. Otherwise they wouldn't pay us. And we did it in 3.5 months. We cleaned the water. But we threw a lot of bacteria. Bacteria is what we call volumetrically driven. The more you throw in, the quicker the result, the more it costs. So we work out the most economic treatment for you guys. The Yanks say more bang for your buck. Okay? So this was just the compaction. I talk about thatching, they're knitting the roots now. They do cross-cut and the greens, and they cut it up because it's the type of grass they're using. And there you can see, that's actually my boss. You can see the compaction of it. It's like, we call it like a puck. All right? And there, after treatment, you can see the different root mass coming up. But I want to show you how the airings went. There's a new airings growing here. Okay, nothing here. Okay. The next one is quite impressive. There you can see that one's out of focus on. You can see the new airings here. And we got the course right. It's ongoing. We are now brewing for them, and they're doing the entire golf course. I'm about to start in East London. Cameron there, we're building a bioreactor for him. We're going to do the entire golf course. They have E. coli. The guys pick up the golf balls, and they don't make 18 holes because they get it on their fingers, and they've got to run. Okay, sewage water. So we're going to be treating the entire course. He has been using our product on his greens for a number of years now, for the same reason, compaction. Okay. So that was a very good trial we did there. We cleaned them up and got great success. I know there's a gentleman here that's into composting, and I believe every farmer should be composting if they have the material. I think it's a fantastic way of rehabilitating your soil and putting it going. This is what I read at Master Organics in Cape Town. It was in the winter, 3rd of May to sometime in June it was. They got no space, so it was just heaped. Normally, composting is in a row, the best way I like it, and you turn it every 7 to 10 days. Why do we turn it? Remember I told you our bacteria is thermophilic? Sorry, is mesophilic. We have to get to the thermophilic stage. We have to get it up as high as 70 degrees to break down all the organics in there. Okay. Our mesophilic dies out when it gets close to 50, 49, and thermophilic takes over. But to get it to there, we need mesophilic bacteria to kick it off. It's a starter. Okay, that's the battery to get it going. Okay. And when you turn it, we put some more bacteria on the top. You turn it, and all the hot comes to the top, and it starts the process again. We'll reduce your composting by 20 days, and we'll give a better quality compost with microbes in it. Okay. So this is the trial we did with these people. Didn't have the space, one big heap. We took, I don't know how many cubic meters front end load, and we dropped it 10 cubes. And we put 2 heaps, we treated the one, the other one we didn't treat. And then we did temperature trials. We want to see that increase in temperature. Okay? And this was the difference between the control, the untreated, and the treated. On 10th of May, we had a 15-degree higher temperature. And as it went, you can see. And then got down to 6.3, and the compost is ready. The minute you get that temperature drop, and you actually see a physical dropping of the windrow, then you know your compost is ready. I think we've got a picture here. There you go. Can you see them both? Okay. The top one was treated. You can see how it's broken down. Bottom one untreated over the same period. The top one's ready to go. She's actually taken compost and she's gone and the lady there and planted in with mustard seed to see what sort of results. She's done winter plants, she's planting to see how effective it is. All right, it's short and sweet.
Sorry, Charlie. Can you just explain in practice how I could do it?
Okay. What we would do is, I would come and measure your slurry pond, give an idea, okay? Dairy waste is pretty simple. Normally if I do any waste, I get an analysis, because I want to know what's in it. What I can break down, what I can't, and what product I'm going to use, what mix of bacterial products I'm going to use. pH should be important, that's my first thing I go for. And then I would see what else, what your CODs are like, what your suspended solids, what your dissolved solids are, and I'd analyze it. And then adjust the program accordingly. And I'll say to you, I can help you or I can't help you. But human animal waste is pretty constant, except on sewage farms where they throw industrial effluent in, which they do a lot of times. Where I live in Montague, we've got a winery effluent coming in, and I'm fighting the buggers against it, because it pushes their CODs up by 50% when they drop that winery effluent. Winery effluent is highly toxic, folks. You can't believe how toxic it is. They've destroyed the entire Breeder River Valley by dumping into rivers. There's a big factory there. We had a flood in 2012 and they put 80 million litres of toxic waste. They just opened the taps and fed it into the river. I used to farm in the Breeder River. There's no more fish. There's barbel. The fish eagles have moved to the dams. You know, it's very sad to see, and that's why I'm doing what I'm doing, because I'm passionate about what I'm doing. I want to leave something for my grandchildren. What was I talking about?
Dairy effluent is pretty simple to treat. You said you don't have to go into too much analysis of how you treat it.
Yeah, so you've got to watch out what's coming in, but with dairy farms, we know the CODs are right, unless you've got very, very bad water. You have a bit of chemicals in it for disinfectant stuff, but normally it's a small volume compared to the rest of the dam. So I measure the dam, I see the volume, and I see, is it just one pond or you go into other ponds? Okay? I will treat the slurry, the first pond, obviously, and then the last one, if you want to get it to a better standard quickly, I would polish it with a low dosage, especially if you're going to be mixing it into a center pivot. But I think most of you guys have 1 or 2 dams. Is that right?
Yeah,
Charles?
mostly, yeah.
And then I would treat the first dam, okay? And it will run over into your second dam and it'll pump out of there. Those microbes will move to the next dam and you'll get bioactivity. You'll see it. You'll see it happening. Where I'm doing patagills out at Thornhill, yeah. Grant and Brett, they just got one. Now, I don't know if you know the setup at Patagills. They put that eco village in there, and they spray the stuff out, and it's a stink. I see lack in it. The city folk don't understand this stuff, you know. And first thing we did was reduce his HTS, no smell. Okay. We've broken it up to slurry. It's liquid now. It's not that hard crust on it. I mean, that was bad. All the flies were breeding. I forgot to tell you, we bioremediate 90% of fly and mosquito larvae. Okay? So whatever breeding there, we'll certainly help you with your fly problem. So, yeah, they're very happy and we're getting a good result there. You know, it's working well. They're chuffed. The new development, the people are happy, and the long term is going to get a good quality fertilizer. That's what it is. Biofertilizer into his pastures. So we're going to see what the trials look like in George when we're going to do rows of the Ripper on pasture, also dairy farmers, and we're going to see if we're going to get a different growth. The reason we want to put it down is to get that moisture, because it's dry land. Okay. So then I'd measure it and I'll give you a recommendation. We've been talking to Charles how we're going to do it. To bring down costs, we get enough people, we'll put up a brew station and we'll brew it. We'll put in a brew and we'll brew bacteria for you. Live bacteria we'll put in. Otherwise, if it's a long way away and it's smaller, we'll just do a normal treatment. I'll use a combination of what we call a back bag, which goes into anaerobic zone. It has recognition compounds, it has oxygenators in it, and it will start breaking down in sludge. And then put I see a 32 in, which is a broad spectrum, and we eat the top off again as it lifts it up. So we will certainly reduce your odors for you. We'll fly mosquito larvae, and we will give you a better quality effluent to spit on your lands. And those microbes are going to go with it. Okay. What else is there, Chris? Or what have I forgotten? Okay. I'm available. I come up to the Eastern Cape. I was actually born in PE. I love the Eastern Cape. I lived back here in the 70s until the world became more Western. I went from hotel to hotel. Now I'm tired of it. But I'm up here regularly, so I'm available to come meet with any of you. So I said, bel as julle bang word. I'm available. Okay. Thanks very much, guys, for listening.
Yeah, thanks, Charlie.
Thanks, Charlie. Appreciate. We didn't really touch much, Charlie, on the agricultural application of the products that they do have. They've done some, incidentally, on pines in South America. So you can see the results that they've achieved on pines. You guys can go and have a look there. And I think one of the problems we've got at the moment, which we've discussed as far as the pineapple industry is concerned, is the actual composting of the plant material once they have finished with the crop. And I think with this kind of solution, we can address this problem to quite a large extent. Thanks, Charlie.
Yeah, thanks, guys. Just to let you know, we're working with everybody we can. I'm busy with the apple tree trial with the Stellenbosch University. It's a 3-year program we're on, and it's in Feyerboom near Grabouw, and we planted on the 27th of October. We've been given 10 trees, and I've got a pipe in the ground. They're doing root scanning. They're doing the whole 2D. And I handed it over to the student, Michelle Weber from Mpumalanga, on 27th of January this year. I just want to show you this, if I may, quickly. I know you guys have got to go back to your farms. And what I did was I said to come and look here. So I said, where our trees have been treated, the guy hadn't taken the weeds out. So we pulled a weed out, actually 2. And I said, select another tree here that's not ours. And she went into that one. We pulled the weeds out. I just want to show you the difference in roots, because I found this absolutely fascinating. And that was from, I don't know how old these weeds are now. Okay. The one on the left came from another tree. The one on the right pulled out for our tree with the bacteria, which is exposed to bacteria. Just look at those roots. Look at those look at the taproot up there and look at the hair root. Compare the difference. If you look at the one on the left, it's dead, it's brown. The one on the right's green, because the taproot is still in the moisture. Very, very poor soil quality. We were talking about one of our agronomists was down there, and it's clay. This particular part's got a bit of sand, but the rest has got this clay bank at the bottom. So we're very excited what we're going to achieve. But if you see those roots, I think we know which one's even better. Look at that up there, you see. So, yeah. That was another one. I think the next one's better. I'm not in the shadow. The one on the left came from another tree, and the one on the right there came from ours. Okay, I just had to show you that. Sorry, that's my little. Thanks, dog.